hour, ladies and gentlemen. So, who else needed a charging block who didn't come up and get one? Anybody? I thought more people needed it. Good. I don't have to go back and get one then.
Really, everything that we did this week is on the quiz.
Well, here's the good news. You can take the quiz from last week.
Instead of this? Okay.
And then on Monday, or Tuesday, you can take the quiz for this week. I got to give it to you when I see you because I don't see you very often.
Okay. For real.
That's what this is.
Sneaking in on me because I didn't shut the door. I get it. Let me shut the door. All right, come on, get logged in, ladies and gentlemen, so I can send you the Pear Deck.
There's a lot of This also isn't helping my case when I say that she doesn't grade my work.
Didn't do the work.
I wasn't here. I wasn't here one day this week. Wait. Was I not here 2 days this week? She always be hating.
It's okay. I like to look.
I wasn't here on Monday.
So wait, are we supposed to keep track of when you're not here, or are you supposed to keep track of when you're not here?
I don't remember when I was not here. I've been out a lot these past few weeks.
I don't think so. It doesn't seem that way, Brindley.
She has to show up.
Hey.
We gotta see her first.
I don't know.
It's okay. I don't either. We'll figure it out as we go, though. Okay, by the way, ladies and gentlemen, here is your schedule for today. Every class starts on the half hour, and you get out at 25. And no home base or advisory today. So after this class, go to your second period class. Do not go to home base, okay? So there is no home base on the schedule today. Yay! I mean, I'm sad about that. I really am. So, okay. All right. So I sent you the Pear Deck, but let's take a look at what we're going to be doing here today. Again, we're still talking about sig figs, ladies and gentlemen. We're talking about being able to express numbers correctly. Why? Because when we do math with our numbers in science, we need to then express those numbers correctly, and that comes into sig figs, ladies and gentlemen. A reminder, you're responsible for things you missed, okay? If you missed something and you don't know how to do it, you need to come and see me. I do still put videos out every day of the lessons that we do in class. So if you're ever missing, you could go to those videos. Now, again, a lot of the videos are the full 71 minutes, but maybe we gave you 20 minutes of work time in there. Sometimes I stop the video, sometimes I don't. So again, you could speed through them if you need to until you get what you need. So we're going to talk about zeros with sig figs, math with sig figs today. I don't know how far we'll get in the math, but we'll see, and then we're going to take our quiz today, okay? That was supposed to be number 5. Number 5 was supposed to be our quiz, okay? We'll do that today. There are no sig figs on the quiz today. Measurement and metric conversions. What was that, Nadia? I'm sorry.
I said that it's not on there, so I don't think we should do it.
Well, again, you're entitled to your opinion, no matter how wrong it may be, but we're still going to take the quiz today, okay? Because it's on the board, okay? So you can't say it's not on the board. It's right there.
I mean, yeah, if I go over there and erase it.
What's that?
Go over there and erase it.
Oh, you need to move to the front, you said?
No. Actually, I can't see it.
No.
Okay, you're right. Let's do a majority rules, okay? So, all those who want to give a quiz today, oh, by the way, in my room, voting age is 35. So, all those who want to give the quiz today, say yes, yes. All those, I don't care about all those who say no. So, okay, here we go. We'll move on.
I'm literally 36.
Okay, yeah.
I'm actually literally 36.
I'm literally 36.
I'm literally 36 right now. I had to send it to you again, ladies and gentlemen, because there were some people who weren't logged in, so I sent it again. So if you got 2, delete the 1. All right.
Oh my God.
Round that number to the 10th place, ladies and gentlemen. Type in your answer. Round that number to the 10th place.
Do it like that.
No.
Wait.
10.
You're right. You're right. Like that. You're right. You're right. That was my mistake. I knew that.
Okay, are we good there?
In my brain, I knew what it was, but I wrote down something else.
Okay. Well, let's see what you wrote down.
Oh, okay. Okay.
Always loved the deleted response before I could show it. So hopefully you had down 30.3, ladies and gentlemen. Good job, good job, good job. Okay, here we go. 30.3 is the correct answer, ladies and gentlemen. The 2 rounds up because of the 9 afterwards. All right, round this number to 3 sig figs. Only 3 sig figs are shown in that number. Well, at least you now know what we've been talking about for the last couple days.
Let me take it.
Now, a good piece of advice, ladies and gentlemen, is after you type in your number, just clear it from your head and then take a look at it and ask yourself, did the number that I just typed in have 3 sig figs? Because that's a good place to start. If not, well, you need to change it. Okay? So, we're not going to show you the responses. We're going to show you the answer. And the answer is 5690, ladies and gentlemen. 5690. Remember, we need the 0 here to hold the place of the 5 being in the thousands place. Okay? And it is not significant. Why? Because there's no decimal. Okay? Now, people are saying, well, what happened to the 4? Well, the 4 wasn't a sig fig. The 4 didn't matter in this calculation, but we still need something in that place. Otherwise, we change the value of our number. So to hold that place but not make it significant, we put a 0 in without a decimal. Okay? We put a 0 in without a decimal. It's like, the object costs $19.99. And if we round that, how much does it cost? $20. Well, what happened to the 99 cents? Well, we rounded it, and now it's closer to $20. Okay? All right, questions? Good. Round the number to 3 sig figs, 2.4. Show that number to 3 sig figs, please. All right, so we round it to 2.4. What does it become?
2.40.
2.40. Maybe.
Oh.
I love when the mouse just starts going.
It flies into the screen.
What do you think it's supposed to do when I'm moving it around?
I don't know, I just think it's funny.
I know.
It just looks
out of
a little
nowhere.
funky.
Well, and the worst part is I'll be doing something, and then I'm like, all right, I hit the button, and it doesn't do anything because I was accidentally on the other screen, changing attendance or something. Okay, 2.40. Perfect, ladies and gentlemen. Questions? All right. So, all right. Cynthia, what did you want us to do first?
Oh, the worksheet, the last 4 on the worksheet.
I think I did that.
This one?
Yes.
Okay. So, all right. If we're going to round these to the hundredths place, now please understand. Right now we're teaching you how to do these things. I don't know of any time really in science where you're going to round a number to the hundredths place. Especially not in this class, because when we take measurements, we're going to measure smaller things.
I'm listening.
Put it away.
It's away.
No, it's not. It's laying on the floor. You want me to put it away for you? I can put it away for you. Okay. So again, we're just practicing this so that you understand how to do it. It doesn't mean that we're going to do this very often. Okay. All right. Count by hundreds from 0 to 1,000, please. Somebody count by 100s from 0 to 1,000. 1,000. So that is how this number of 785,322 has to end. It has to end like 100, 200, 300, 400 if we're going to round to the hundreds place. Okay? So, which digit is in the hundreds place? And I know you can't see it right now because I'm bringing up this. Which digit is in the hundreds place, ladies and gentlemen? No, the 3. The 3 is in the hundreds place. Okay? So that's where we're rounding it. Okay? So now we look at the number afterwards. It's a 2. Do we leave that 3 or do we round it up? We leave it. So this becomes 785300. That is that number rounded to the hundreds place. It has to end as 100, 200, 300, 400, 500. Questions? Now, the next one says round to the tens place. Well, that has to end 10, 20, 30, 40, 50, 60, 70, so on and so forth. So, which digit is in the tens place? That would be the first 2 here. The number after is a 2, so do we round it up or do we leave it? We leave it. So again, the 7, the 8, the 5, the 3 still come in here. Now we leave the 2, and what do we do with that last place? Put a 0. Put a 0. Okay? Now, the next one is rounded to the ones place, right? Well, what place is this number in already? The ones place. So just recopy the number down. 785322.
So we'll have to add an extra 0.
No, do not add an extra 0 because then you would be, if you added an extra 0, that would be to the tens place.
Okay. Oh yeah.
Now, if they wanted you to go to the tens place now, yes, you would put in a decimal and a 0. If they wanted you to go to the hundreds, you'd put in a decimal and 2 zeros. You can round to any place, a number to any place you want. Okay? Now, why would you round to a certain place? That we'll get into when we talk about the rules for sig figs with math. Okay? But understand, you can round a number to any place you want. All right. So, 7,230 rounded to the hundreds. What would it be? 7200. How about rounded to the tens?
7230.
It's already in the tens. How about rounded to the ones?
It'd be the same number again.
No.
What? What? Why not?
Well, because what place is this ending in?
You put a decimal.
The one.
You put a decimal. Very good, Brinley. You're right, Miro. It is the same number. I'm sorry, I kind of jumped on that. It is the same number, but we have to put a decimal after it because it makes that 0 what?
Significant.
Significant. Now it says it's ending in the ones place. Does that make sense?
But we're just rounding the places. Why would it matter if it's significant or not?
Because when they say round to the ones, we want that ones to be a significant place then.
Okay.
Because otherwise, if we don't put the decimal in and it looks like this, it looks like you rounded to what place?
The 10.
Yeah. So we want to show somebody that that ones place actually means something. That 0 was actually measured. We do it by putting the decimal in. Okay? All right. Good? Any others? Do you want me to go through the next 2, Cynthia, or no?
Yes.
Yes. All right. 538.897 rounded to the hundreds. What would it be, Cynthia?
I don't know.
Okay, well, what digit is in the hundreds place?
80.
Hundreds. Hundreds. Not 0.1, not ones. 100. What's the third digit in this number to the left of the decimal?
Oh, 9. Or 7.
Your other
To the
left. Your other left.
Oh, 30.
Let's slow down. Third digit to the left of the decimal.
8.
Please.
Do that last
First
one.
one.
Oh my
The
God.
first one. Sorry.
I can see why you're struggling a little bit with the rounding here, okay?
What?
Which digit is it? The 5, right?
Yes.
Okay, what number is after it?
3.
So do I leave that 5 or do I move it up to a 6?
You leave it.
Okay, so give me the number in the hundreds place.
530.
500, 500. Remember, to round to the 100 place, your number has to be something like 100, 200, 300, 400, 500, 600.
Oh, so the 3 turned into 0 and the 8 turned into 0?
Yes,
Because you
Okay.
can round it up.
correct. Okay, what about rounding this to the tens place? Now we're looking at the 3, right? What number is after the 3?
8.
So what does that make it?
4.
540. Okay. What about rounding to the ones place? Well, now we've got an 8 in the ones place. After it is an 8, so what does that become?
39.
Now, which of these three numbers is the most precise number, ladies and gentlemen?
539.
539. Now, we haven't gotten into precision yet, but you're absolutely correct, Miro. And this is why when we take measurements, we want to be as precise as possible. So we don't take a number like 539 or 538 and round it to 500 because we can only show one sig fig. Okay? All right. So what would 79.43 be rounded to the 100s place?
100.
Would be 100. Now you may be looking at that and go, man, that's a lot of rounding, right? Well, there's no digit in the hundreds place. It's a 0, but the number after it is a 7, right? So we have to make it 100. All right. What about rounded to the 10s? What would this be?
80.
And rounded to the ones?
79.
79. Questions? We're good? All right, please make sure you turn this worksheet in before the end of the day today. All right. So, ladies and gentlemen, with that said, let's take a look at this slide about holding zeros to hold place values. Okay, so please open up your EISN and get to this slide. What number is it in your slides if somebody is there, please? Sure, go ahead.
It's a valid question.
I understand, but right when I'm getting into teaching, that's when you're asking.
Well, I mean, I'm gonna relearn this again, so it's okay.
Okay. All right.
Wait, what slide is it?
Did somebody find it in yours? Because I know it's not 55 in yours.
46.
I'm sorry?
46.
46. Thank you. Okay, zeros are sometimes needed when rounding to hold place values. For example, if we round 12,569 to the tens place, and this is what we've been doing, this is what we've been talking about. The 6 is the digit in the tens place. The 9 after it means we round it up. If we made it 1,257, we have the correct digits, but without a 0 at the end, we've changed the value of the number. We've gone from a number around 12,000 to a number around 1,000. Can't do that. So we have to put a 0 in to hold the place value. Now it is not significant. Why?
Because there's no decimal.
Because there's no decimal, and that's fine. So we use zeros at the end of a number sometimes to hold places but not be significant. Zeros can also be needed if we are rounding a large number to a small amount of sig figs. So for example, rounding 45,869,325 to 4 sig figs. Okay? The 6 is the 4 sig fig. So now in reality, we are rounding to a place once we find where that digit is. So this is the 10,000s place. 10,000s place. And we're rounding it to there. Well, the 9 after says make that 6 a 7. So our answer ends up being 45,870,000. Questions?
No.
Good. So if we are rounding this number to the tens, the 1 is in the tens place. The decimal to the right is a 2, so we're going to leave it. We're not going to round it up. So this number becomes 32,610. A 0 at the end to hold a place value, not to be significant.
Why don't we just leave the 2?
Because we're rounding to the tens place and we can't go any further than that.
Okay.
Okay? So for some reason, we are stuck rounding to the tens place. Okay? Again, we will explain why when we get into the rules a little bit later. When you add, subtract, or multiply and divide, there are rules that will limit the sig figs. Okay? And again, that might be what you get out of your calculator, but your calculator doesn't do sig figs. So because of that, we have to round this number to the tens place for whatever reason. Okay? If we're taking this number, 4,256.789, and rounding to the hundreds, the 2 is in the hundreds place. The 5 afterwards means that we're going to round it up, so our number becomes 4,300. Okay? Again, Why we're doing this is because we have done the rules for sig figs and our measurements say we can only go with this to the hundreds place. Okay? If we're in the thousands place here, that is where the 3 is. The 6 afterwards means we're going to round up, so this would be 24,000. Okay? This would be 24,000. Questions? Okay. The number 356,214 to 3 sig figs. The 3 is the first, the 5 is the second, the 6 is the third sig fig. So now in reality, we are rounding this to the thousands place, just like the one above it. Okay? The 6 is there. The 2 afterwards means we leave it and we move it up to, or we make the number 356,000. 3 zeros at the end to hold the places, but not become significant. 1,289. The 2 is the second sig fig. So now in reality, what we are doing is we're rounding to the hundreds place. The number after the 2 is an 8. So what do we do to the 2? We round it up. So this becomes 1,300. Okay? 1,300. And if we had the number 163 and we're rounding to 1 sig fig, that means that the 1 is the sig fig that we are rounding to. We're rounding to the hundreds place here. The 6 after tells us to do what to the 1? Round it up to 200. Okay? Now, I know it's weird. Why would we round that number to 200s? Why would we? It goes into the rules of sig figs that we're going to talk about in a little bit. Okay? All right. Now, sometimes zeros are added to get to the right place value or the right number of sig figs. So, for example, if we have 12.3, but we need our answer to the hundredths place, there's no digit in the hundredths place here. So we're going to add a 0. Will it be significant? Yes. Because of the decimal, they will be significant. In that last one, none of these zeros at the end are significant. They're just holding places. But now, we need our value to be to the hundredths place, but our calculator gave us 12.3. So how do we make this to the hundredths place? We add a 0 to the end, ladies and gentlemen, 12.30. How do we make 2.3 to 3 sig figs? Our math says the answer is 2.3. But we needed 3 sig figs. We put a 0 on the end, ladies and gentlemen. We can put zeros on the end and they can be significant. So for example, 123 to the tenths place, there's no digit in that spot. There's no digit to the right, so we're going to add a place as a 0. So our answer is going to be 123.0. 16 to the hundredths, that's 2 places beyond the decimal, 0.01, would mean, again, there's nothing there. We're going to add zeros to get to that place, 16.00. Okay? Now, this is something that you will see more commonly. We took a mass divided by another mass, and our calculator gave us 3.6. But our balance reads to the thousands place, so we need to stay in the thousands place. So what do? We add zeros to show that we measured to that place. Okay? Even if we had to put an answer in 3 sig figs, but our math gave us 0.2. Well, we're going to add 2 more zeros to make it 2.00. Now, in all of these zeros are what? They are significant. So sometimes you need to add zeros and you want them to be significant, and that's what we're doing here. If the number we got out of our calculator was 4,523, but we want to be to 6 sig figs, we are going to add places to get there. We would add 2 more zeros because we have 4 already sig figs here. 2 more zeros would give us 6. 3 sig figs here. To get to 5, we add 2 more zeros. Okay? We add the zeros at the end. We put the decimal in. It makes them significant.
Oh, thousands, not thousands. Okay.
What did I say?
You said thousands. The third one down.
Third one down. Thousands?
You wrote thousands.
Oh, sorry. Yes, thank you. Typo. That should be thousandths. TH. Sorry. My bad. My bad. Thank you. Hey, congratulations. You're my 4th class that I've given these notes to, and you're the first person who found that error. Good job. Good job. Okay? All right. So, again, scientific notation is sometimes important with sig figs, because the only way to write certain numbers to a certain amount of sig figs is to sometimes put them in scientific notation. The number 12,000, there is absolutely no way for you to write it to 3 sig figs. If we drop a 0 and put a decimal, we've changed the value to 120. If we put a decimal at the end, there are 4 sig figs. So the only way to do this, to control the sig figs, is to put it into scientific notation and make it 1.20, because that would have 3 sig figs. Times 10 to the 3rd. Now, times 10 to the 3rd means that I'm going to slide my decimal 3 places. But this is the way that I could say, okay, there's only 3 sig figs here, even though this is the number that I had and that I'm trying to express.
Is that going to be on test?
No. No. And to be honest, you'll probably very rarely, if ever, run into a situation like this. Very rarely. But if you were, okay, probably not in here. If you take college chemistry, you may have to put numbers into scientific notation to express sig figs. Okay? It does happen occasionally. Okay? I'm not going to give you things like this, though. Okay? So the same way, if you have the number 34,999, if we round this to 3 or 4 sig figs, 3 sig figs is right here. But with the 9 after this, what happens to this 9? It gets rounded up, right? So that becomes 35,000, and now it's 000. Okay? So there's no way to write this to 3 or 4 sig figs. There's no way to write 5 sig figs. I put a decimal at the end. 2 sig figs I have here. But 3 or 4, there's no way to do it without putting it into scientific notation. So here it is in 3 sig figs. Here it is in 4. You control how many zeros you show here to control how many sig figs. Questions? All right. So, what would this not... Okay, now, first of all, for scientific notation in your computer, ladies and gentlemen, if you want to make that power, that times 10 to the 23rd power, on your keyboard, if you hit the control button and the period key, you will type in superscript mode. You will be able to put that power up above. Okay? So on your computer, first of all, 3 sig figs. What would the base number be for this in 3 sig figs? 2.00. Then you would do times, which is an X, 10, and then you would hit the control and the period key on your keyboard. Now, what power should this be to when we slide our decimal to get a number between 1 and 10? How many places do we slide the decimal that's at the end here? I know it's not shown, but how many places would we have to slide it?
4.
We'd have to slide it 4. So your number should be 2.00 times 10 to the 4th. Questions? So what happens to this next one when we go to round it to 3 sig figs?
It gets rounded.
Becomes 130, right? Actually, this one you could do without writing into scientific notation. How would we write 130 so that that 0 is significant?
With a decimal.
We could put a decimal after it. No 0 after it, but we could write it as 130. If we made this into scientific notation, it would be 1.30 times 10 to the what? Times 10 to the 2nd. This one you could get away with without doing scientific notation, though. Can we get away with this one without doing scientific notation? You bet we can. There's 4 digits here. If I put a decimal at the end, that makes them all significant, right? Okay. But in scientific notation, we would slide our decimal 3 places to get it between the 8 and the 9. We would have 8.900 times 10 to the what power?
That's not the door. So 30.
10 to the third. Okay, thank you. All right. So this one, it really doesn't pay to put it into scientific. That's 10 to the fourth. Really doesn't pay to put it into scientific notation. Sorry, we were talking about this one, weren't we?
Yep.
I jumped ahead. Sorry. Putting this number in scientific notation is more work than just putting the decimal. Same thing here. Okay. Sometimes that happens. This one, there's no way you can put it into 4 sig figs without putting it into scientific notation. 5.630 times 10 to the fourth. Questions? All right. Well, we need to stop now and we need to take a quiz. So this is as good a place as any to end. You're going to need a calculator, ladies and gentlemen. So if you don't have one, please go up and grab one of mine. I'm also going to give you scratch paper because on the quiz, you may not need it. You won't be doing the ones with that. On the quiz, you're going to have to convert from one unit to another, and that you can do on here if you need to. If you don't need to use the scratch paper, you don't have to. I'm just giving it to you in case you need it. Here, take those two. If there's a third, give it to Haley. Is there a third there? Okay, good. Again, you do not need to use the scratch paper unless you need to. I am going to give you the conversion. In the question, it will say to convert from grams to kilograms, 1,000 grams equals 1 kilogram. You do not need to know the conversions, you just need to know how to use them. Okay? All right, ladies and gentlemen. Okay, sorry, yours is on the paper.
Me when I'm okay.
All right.
I hope so.
All right, there's the quiz, ladies and gentlemen. It's in Google Classroom. It's open for you. Click on it. Go ahead and begin, ladies and gentlemen. If you have questions, please raise your hand, call me over, and I will answer them. Okay? Shh. I didn't spring a leak. That was me asking you to be quiet. Go to work. Go to work. Yet you're still talking. Finish your quiz. Then you can talk when everyone is done.
Are we all done?
You're not even done, but you may be done in another way.
Yeah, I'm actually gonna go home. What? Okay? No. 4 questions, you liar.
How many did I say?
You said 4.
Oh, I lied a little. Sorry.
Jesus.
Nope, I'm not Jesus. Nope.
I know
Nope.
you're not.
Nope.
You make miracles happen. Okay.
It's possible. You might learn chemistry. I could make a miracle happen.
God, I need God.
I don't think prayer is going to help at this point.
This is really funny.
I swear I need popcorn from the conversation.
What?
I swear I need popcorn from some of the conversation.
Need popcorn.
Yeah, I need Advil for some of the conversations that we have in class. Will you two quit talking? You and Cynthia. The Diary of the Mouth Twins.
Whoa, that was really good.
You like that?
You were looking at me. You were like, exactly. You were looking at me like that. Why would you? Are you so angry? Move it around, trying to find answers.
That'd be a place that I would start.
Yeah, I'm trying. I can't read it though.
Oh, sorry. I'd look at your periodic table then.
That's my periodic table doesn't help anything.
This is what we wrote.
So we're gonna cover.
Okay, I'm gonna solve this problem for the next bit by spreading you out throughout the entire room. If you don't stop talking.
Wait, why'd you put like two different things in? Am I just done?
Be careful, there are some questions where you have to select all that are correct.
No, I
Oh, typo in the, oh my goodness.
Oh yeah, I noticed that.
Yeah, the second one should say 1,000 millimeters equals 1 meter, not 1 kilometer. I'm sorry about that.
Okay, I was.
Yes,
really
that's,
confused
yeah,
with that.
I will correct
This is
that.
1 meter?
1 meter,
That's
yes.
1 meter.
1,000 millimeters equals 1 meter, not equals
Wait.
1 kilometer. Sorry about that.
Wait, are we going from
So-
kilometers to meters then?
Yes.
It's millimeters. We're going from
Wait,
kilometers.
Kilometers
hold on,
to
sorry,
millimeters.
pause. So it's one. This.
What? 1,000.
Listen, just shh. Let me just relax. For the question, I need to find it. Chill out for a second.
Yeah.
You can handle the answer. You are going from 0.235 kilometers
2 millimeters.
to millimeters. 1,000 millimeters equals 1 meter. That is correct. The typo is 1,000 meters equals 1 kilometer. Okay? That is the typo in there. I'm sorry about that. I'm fixing it right now.
The typo is the first one. The
Yeah.
second one's right.
No, the second's not right either. The second-
1,000 meters equals 1 kilometer.
Yeah, that was.
And then it says 1,000 millimeters equals 1 kilometer.
Oh, why
Yeah.
was right?
Okay.
1,000 millimeters equals 1 meter.
I'm with it now.
1,000
Dude, do the table.
millimeters equals 1.
Dude,
Meter.
It's 2 M's and 1 M.
That's
Yeah, because you're going from kilometers to millimeters. Wait, is that what it is?
Yes.
Yeah.
These are correct. And these are the two that you need to use to get from here to here. Okay? Remember, when you're going from a prefix to a prefix, it's a 2-step problem. These are the 2 steps that you would need to get from here to here.
Wait.
Yeah. Remember what the definition was.
So is this set up right? I know it's right.
But your units are canceling. You can do the correct ones now that I come up with them, so Don't forget your unit when you give that answer.
Thanks. I tried. This is closer.
25.
Okay. You don't have to use them in the order I gave you. Which one you go to?
Because you're going to use this. Just like put that one. Put that one.
Okay. What would you put on the top?
And then this is one.
No, yeah. Okay, so
And
the
then-
meters.
But then I do this. And then I do.
I'm glad you
I
had
thought-
that conversation because you really did all the work.
Because I thought that you had to do it in
No,
order. And
they're
then I
not,
was
no,
confused.
not in order,
Yeah.
sorry.
Alright, well, I'm good now.